Hello everyone and welcome back to my channel. This would be the fourth video on NCERT class 10 chapter 4 quadratic equations, and in this video I'm going to solve exercise 4.3 question number 2. Find the roots of the following quadratic equations using the quadratic formula. So let's first try to understand what is your quadratic formula. Okay? In quadratic formula, the coefficient of x square is taken as a. A denotes the coefficient of x square. B denotes the coefficient of x. And C denotes your constant term. Now we need to find out a certain quantity known as discriminant. Discriminant denoted by capital D, and discriminant is given by the formula b square minus 4ac. Okay? In quadratic formula, A represents coefficient of x square, B represents coefficient of x, C represents the constant term. We need to find out another factor known as discriminant. Discriminant is given by the formula b square minus 4ac. Now, the value of discriminant can be positive, it can be negative, or it can be equal to 0. So the first condition, if the value of discriminant is equal to 0, okay, you use this formula b square minus 4ac to obtain the value of discriminant. If the discriminant is equal to 0, then the roots of your quadratic equation will be real and equal. Means the roots that you obtain will be real numbers and they will be equal. So if this is equal to 0, then the roots of the given quadratic equation, the roots of the quadratic equation will be real and equal. Real and equal. Alright? The second case is if D is a positive quantity, if your discriminant is a positive quantity means if it is greater than 0, then the roots of the equation will be real and distinct. Roots of the quadratic equation will be real and distinct. Means the roots that you obtain will belong to real numbers and they will be different from each other. Distinct means different, okay, from each other. The third case, if D is less than 0, means if you are getting the discriminant as a negative quantity, means less than 0, then in that case no real roots can be obtained. In that case no real roots can be obtained. And in the first two cases, if D is equal to 0, then we have roots, we can get the roots which are real and equal. If D is greater than 0, then the roots of the quadratic equation are also real but distinct. In the above two cases, okay, we can find out the roots by using the formula. Roots means value of x which satisfies your given equation, right? Value of the variable which satisfies your given equation. So we can obtain the roots by using the formula minus b plus minus square root of d upon twice of a. So in cases if d is equal to 0, or if d is greater than 0, then we can obtain the real roots of this equation, of the given equations, of the given quadratic equation. And using this formula, minus b plus minus square root of d upon 2a, we can obtain the roots of your given quadratic equation. So this particular concept, or this particular method of finding the roots, is known as your quadratic formula, or we call it as Sridharacharya formula. Okay, it was invented. This formula was invented by an Indian mathematician whose name was Sridharacharya, so it was given under his name. So let's simplify, let's solve, or let's find out the roots of this first given quadratic equation using the quadratic formula. Here the coefficient of x squared is 2, so a is 2. Coefficient of x is minus 7, so b represents coefficient of x, which is minus 7. And your constant term c is equal to 3. A represents coefficient of x squared, b represents coefficient of x, and c represents the constant term. Now let's find out the discriminant. Discriminant is given by b squared minus 4ac. Your b is minus 7, so minus 7 squared minus 4 times a is 2 times c is 3. Minus square is positive, 7 squared gives you 49. Minus 4 2 times is 8, 8 3 times is 24. 49 minus 24 is 25. So the value of discriminant is 25. It's a positive quantity which is greater than 0. So we can find out the real roots of your given quadratic equation. Therefore, we can say that roots are real and distinct. We can find out the real roots of your equation, given quadratic equation, and the two roots that you obtain will be different from each other. That is what is meant by distinct. So let's find out the roots using the formula x equals to minus b plus minus square root of d upon twice of a. So this formula is known as your quadratic formula. Using this formula we obtain the roots. So minus from the formula, your b is minus 7, so I have to introduce a bracket, okay, and minus 7. Minus from the formula, b is minus 7, plus minus square root of d, which is 25, upon twice a, 2 into your a is also 2. Twice a, so 2 into a, that is 2. Minus minus plus, so 7. Plus minus square root of 25 is 5 upon 4. Now there are two possible values. First value of x will be given by 7 plus 5 upon 4. And the other value of x will be given by 7 minus 5 upon 4. So let us separate them. So either your x will be 7 plus 5 upon 4, or your x will be 7 minus 5 upon 4. 7 plus 5, 12 upon 4, which gives your x to be 3. 7 minus 5, 2 upon 4. 2 1 times is 2, 2 2 times is 4, so 1 by 2. Therefore, the roots of your quadratic equation are 3 and 1 by 2. So these are the roots of your quadratic equation. Roots are real and distinct. 3 is a real number, 1 by 2 is a real number, and they are different from each other. So we satisfies this condition that roots are real and distinct. So that completes the first one. We'll go for the second one. There are 4 questions altogether. Okay, after Roman number 4, 4 given quadratic equation. We have to determine the roots, okay, if they are real. Roman 2, let's see the given equation. Twice x squared plus x minus 4 equal to 0. Your coefficient of x squared is 2, so a is 2. Coefficient of x squared is represented by a. Here, coefficient of x will be 1. Okay? Coefficient of x is 1. So b will be 1. And your constant term is minus 4. So let's find out the discriminant. Discriminant is given by b squared minus 4 times ac. Your b is 1, so b squared means 1 squared. Minus 4 times a is 2, c is minus 4. 1 squared is 1, minus into minus plus. 4 2 times is 8, 8 4 times is 32. 1 plus 32 is 33. Now the value of this 33, it's a positive quantity, so which is greater than 0. So just like the first case, okay, just like the previous one, here since these 0, so roots exist, okay, and roots are real and distinct. Roots are real and distinct. Now let me use the quadratic formula for finding the roots. X is equal to minus b plus minus square root of b upon twice of a. Minus from the formula, your b is 1, so 1 plus minus square root of 33 upon 2 into a, your a is 2. Minus 1 plus minus square root of 33 is an irrational number. So we are going to leave this irrational number as it is upon 2 times is 4. So let me separate out the terms. Therefore, either your x will be minus 1 plus square root of 33 upon 4, or x equals to minus 1 minus square root of 33 upon 4. This cannot be simplified further because square root of 33 is an irrational number, and hence we cannot add or subtract with this minus 1. So this is your first root. Your first root is minus 1 plus square root of 33 upon 4. And the other root is minus 1 minus square root of 33 upon 4. If this is done, we can straight away go for Roman 3. So your Roman 3, your given quadratic equation is 4x squared plus 4 root 3x plus 3 is equal to 0. Here the coefficient of x squared is 4, so a is 4. Coefficient of x is 4 times square root of 3, so b is 4 square root of 3, and then your constant term is 3. So let's find out the discriminant. Discriminant is given by b squared minus 4ac. The value of b is 4 square root of 3, and then we have square, so holding square, minus 4 times a is 4 times c is 3. 4 square is 16 times square root of 3 square is 3. Square and square root, they will cancel out each other, so we have 3. 4 times is 16, 16 3 times is 48. 16 3 times is 48 minus 48, which is equal to 0. Now we have seen that if the discriminant is 0, then we have real roots and they will be equal. Therefore, roots are real and equal. Now let us obtain the roots by using the quadratic formula. Minus from the formula. your b is 4 square root of 3 plus minus square root of d. D is your 0, so square root of 0 upon 2 into a is 4. Square root of 0 is always 0. So minus 4 square root of 3, we have plus minus 0 upon 8. Okay? So either your first root will be minus 4 square root of 3 plus 0 upon 8, or x equals to minus 4 square root of 3 minus 0 upon 8. So this is equal to minus 4 square root of 3 upon 8. 4, 2 times is 8, so that's minus square root of 3 upon 2. Here we have minus 4 square root of 3 upon 8. 4, 2 times is 8, so minus square root of 3 upon 2. So both the roots that we have obtained are real. They belong to real number here. Minus square root of 3 upon 2. It's an irrational number. Irrational numbers are real numbers. Here also real numbers. Both of them are equal, so it satisfies the condition that roots are real and equal. Right? Now let's go for a fourth one. Roman 4. What do we have in Roman 4? Your given equation is twice x squared minus 7x plus 3 equals to 0. Here the coefficient of x squared is 2, so a is 2. Coefficient of x is minus 7, so b is minus 7, and the constant term is 3. Now we find out the discriminant, which is b squared minus 4ac. Your b is minus 7, so minus 7 squared. Minus 4 times a is 2, c is 3. Minus square is positive, 7 squared gives you 49, minus 4 2 times is 8, 8 3 times is 24. So which is equal to 25. So the value of d that we have obtained is 25. Let me check the question. Twice x squared. Oh, there is a certain problem with the question. In Roman 4, the question is twice x squared plus x. Plus x plus 3. I'm sorry for the mistake here. So your equation is twice x squared plus x plus 3. In that case, your coefficient of x is 1. Coefficient of x is 1 here. Okay, x means coefficient is 1. And then we have 3 here. So your d will be b squared minus 4ac. So 1 squared minus 4 times 2 times 3. 1 square is 1, minus 4 2 times is 8, 8 3 times is 24, 1 minus 24 is minus 3, or minus 23. Now this time the value of the discriminant is negative. Negative means less than 0, so no real roots can be obtained from your given equation. Therefore, no real roots. That means your given quadratic equation has only imaginary roots. We call it as complex roots, which you are going to study in your class 11 science. If you take up science, then in your mathematics, we have a course on complex numbers. Then you will study how to determine the complex roots of a quadratic equation. So with this Roman 4, question number 2 is complete. So we proceed with the next question, question number 3. Here also we are asked to find the roots of the following equations. So this is your given equation. X minus 1 by x is equal to 3. This is your given equation. Here x can take any real number except that it should not be 0. Because if you take x as 0, then 1 by x becomes 1 by 0, and 1 by 0 is undefined. Okay? So if you consider your x to be 0, if you take the value of x to be 0, then your equation becomes undefined. So here we are not supposed to take the value of x to be 0. Apart from that, x can be any real number. So this is your given equation. First of all, we are going to reduce this equation to a quadratic equation. Okay, we have to reduce the given equation to a quadratic equation, and by applying the quadratic formula, we will obtain the roots, because that's our objective. Find the roots of the following equations. So the given equation has to be reduced to quadratic form, and then we find the roots using quadratic formula. So your given equation, x minus 1 by x is equal to 3. Here we have 1 in the denominator. So the LCM of 1 and x, the LCM of 1 and x will be x, right? Okay. X divided by 1, LCM will be divided by 1 here. X divided by 1 is x. X times x is x squared. X divided by x now 1. 1 times 1 is 1 is equal to 3. 3 we can rewrite it as 3 upon 1 if you cross multiply. X squared minus 1 times 1 is x squared minus 1. 3 times x is 3x. Now let us rearrange. X squared, let's bring this 3x to the left side as minus 3x, and then we have minus 1 equal to 0. Since in this equation the highest power of the variable is 2, order is 2, so it's a quadratic equation. So we are going to apply the quadratic formula for finding out the roots. But let's check whether roots exist. Okay, here coefficient of x squared, we have a term containing x squared, so its coefficient will be 1. So coefficient of x squared is 1. The coefficient of x is minus 3, so b is minus 3. Constant term is minus 1 again. So your discriminant will be b squared minus 4ac. b is minus 3, so minus 3 squared. Minus 4 times a is 1, c is minus 1. Minus 3 squared is 9. Minus into minus plus 4, which is 13. 13 is greater than 0. So roots exist, they are real, and they are distinct. Therefore roots are real and distinct. So we can obtain the roots by the quadratic formula. X equals to minus b plus minus square root of d upon twice of a. Minus from the formula, your b is minus 3, so I'm going to use a bracket and write minus 3, plus minus square root of d is 13, upon twice into a, coefficient of a, x squared is 1, so a is 1. Minus minus plus, we have 3, plus minus square root of 13 upon, square root of 13 is irrational, so we cannot express it in the more simpler terms. So we find out the roots by separating the terms. So your first root will be 3 plus square root of 13 upon 2. That is the first root, as we cannot add 3 and square root of 13. And your second root will be given by x equals to 3 minus square root of 13 upon 2. So these are the two roots of your given equation. Alright? Okay. So now we go for the next one. So Roman 2, let's go for Roman 2. In Roman 2 we have 1 upon x plus 4, 1 upon x plus 4 minus 1 upon x minus 7 is equal to 11 by 30. And also x is not supposed to be minus 4, x is not supposed to be 7. Okay? So let us simplify. It does not look like a quadratic equation, so what we have to do is, first of all, we have to reduce it to a quadratic equation, and then we can find out the roots if they are real using the quadratic formula. So let us take the LCM on the left hand side. Here your denominator is x plus 4 and x minus 7. X plus 4 and x minus 7, they are not multiple of each other. So in that case, if the denominators are not multiple of each other, then your LCM will be product of denominators. LCM will be the product of denominators. Means x plus 4 times x minus 7 will be your LCM. Now this LCM has to be divided by the first denominator. So if you divide this term by your denominator x plus 4, then x plus 4 cancels out each other. So x minus 7 times 1 will be x minus 7. Alright? With minus over here. Again, LCM will be divided by the second denominator. If you divide this LCM by your second denominator, then x minus 7 will cancel out each other with x plus 4. X plus 4 times 1 is x plus 4. We use a bracket because there is a negative sign that has to be multiplied, which is equal to 11 upon 30. So x minus 7 minus x, we have minus x minus plus minus 4 upon, let's evaluate their product, x into x, x square, x into minus 7 minus 7x, plus 4 times x is 4x, 4 times minus 7 is minus 28, which is equal to 11 upon 30. Plus x minus x cancels out each other. Minus 7 minus 4, minus 11 upon x square. Minus 7x plus 4x minus 3x. And then we have minus 28 is equal to 11 upon 30. If we cross multiply, 11 is going to multiply with all of this term. 11 times x square minus 3x minus 28 equals to minus 11 into 30, 330. Now instead of multiplying all these terms by 11, it's better we transpose 11 to the other side. Then it comes as division, right? Okay. So x square minus 3x minus 28 will be equal to minus 330 upon 11. 11, 3 times is 33 and 0. So we have minus 30. So this implies x square minus 3x minus 28 is equal to minus 30. So x square minus 3x minus 28, let us transpose minus 30 on the right side to the left side. So plus 30 is 0. So x square minus 3x minus 28 plus 30 gives you plus 2 equals to 0. So your given equation has been reduced to a quadratic equation. And now we are going to find out the roots of this quadratic equation by using the quadratic formula. So here your coefficient of x squared is 1, so a is 1. Coefficient of x is minus 3, so b is minus 3. Constant term is 2. Now we have d, which is b squared minus 4ac. Here b is minus 3, so minus 3 square. Minus 4 times a is 1, c is 2. Minus 3 square is 9. Minus 4 2 times is 8. 9 minus 8 is 1. 1 is a positive quantity greater than 0. So we have real roots and they are distinct. Therefore, roots are real and distinct. Now we shall obtain x. We shall obtain x by using the quadratic formula minus b plus minus square root of d upon twice a. Minus from the formula. Okay, minus from the formula. Your b is minus 3. So under the bracket, I'm going to write minus 3 plus minus square root of d is 1 upon 2a. 2 into your a is 1. So minus minus plus, so 3 plus minus square root of 1 is 1 upon 2. So let us separate the terms. So therefore either your x is going to be 3 plus 1 upon 2, or your x is going to be 3 minus 1 upon 2. So 3 plus 1 is 4, 4 upon 2, there is 2. Here 2 upon 2, 2 1 times is 2. Therefore the roots of your quadratic equations are 2 and 1. The first root is 2 and the second root is equal to minus 1, which completes the second question. So let us go for the third one, Roman number 3. In Roman number 3, we have there is no Roman number 3 here. Okay, so in question number 3, we have only worked out with Roman 1 and 2. And I think that is enough for this video.